That orange juice you drink every morning? It's not what you think it is. When you see "from concentrate" on the label, you're drinking something that was completely stripped of water, frozen into a syrup, then reconstituted with filtered water and artificial flavor packs made from orange oils. But here's the shocking part. Even not from concentrate juice goes through a process that removes all oxygen and natural flavors, which are then replaced with laboratory-created flavor compounds. Today I'm taking you inside the massive factories where your orange juice is really made. A single truck arrives at the factory carrying enough oranges to fill your refrigerator for 30 years. But what happens next will change how you see that morning glass of juice. The gondola truck tilts its massive bed, and 120,000 oranges cascade onto conveyor systems, moving at speeds that would make your head spin. These aren't the gentle, rolling belts you might imagine. The conveyors race along at 400 feet per minute, carrying oranges toward their fate faster than you can walk. The clock starts ticking the moment those oranges hit the factory floor. Spoilage begins within hours once the fruit leaves the grove, and factories know they're racing against chemistry itself. Enzymes inside each orange are breaking down cell walls, turning sugar into alcohol, and creating the conditions for mold growth. This forces processors to move fruit through the system faster than nature ever intended, creating an industrial assembly line that operates like a precision machine. The hydraulic platform system handles this massive load with mechanical precision that prevents crushing the delicate fruit. 2 tons of oranges move through the system every single minute, supported by carefully calibrated rollers that cradle each piece of fruit. The platforms tilt at exact angles calculated to maintain optimal flow rates while preventing the weight of 80,000 oranges from crushing the ones below. Engineers designed these systems to handle fruit that varies in size from golf balls to softballs, all moving together in perfect harmony. Random sampling happens through trapdoors that open automatically every few minutes, collecting 40-pound batches for laboratory analysis. Technicians test these samples for sugar content, measured in degrees Brix, acidity levels, and moisture content that determines juice yield. The lab results feed back into the processing system within minutes, adjusting conveyor speeds and sorting parameters to match the specific characteristics of each truck's cargo. High-pressure washing stations use alkaline solutions and spinning brushes that strip away more than just surface dirt. The washing process removes field dust, pesticide residue, and natural wax coatings that oranges produce to protect themselves. Industrial detergents, with pH levels around 11, dissolve organic matter while rotating brushes scrub each orange for exactly 12 seconds. The rinse cycle uses filtered water heated to 110 degrees to ensure complete removal of cleaning chemicals. Optical sorting technology rejects imperfect fruit at speeds human eyes cannot match, creating perfect uniformity for the extraction process. High-resolution cameras capture 40 images per second of each orange as it passes under specialized lighting. Computer algorithms analyze color gradients, surface blemishes, and shape irregularities in milliseconds. Rejected oranges get blown off the line by precisely timed air jets, while acceptable fruit continues towards size sorting. Size sorting rollers must match each orange to its exact extractor size for maximum juice yield. The rollers gradually spread apart as oranges roll forward, allowing smaller fruit to drop through gaps onto lower conveyor belts. Large oranges continue rolling until they reach their designated size channel. This sorting process ensures that each orange fits perfectly into extraction equipment designed for specific diameter ranges, preventing juice loss from poor fits. This industrial precision extracts 30% more juice than manual methods, but at the cost of natural variation in flavor. Every orange follows an identical path through identical processes, creating consistency that eliminates the subtle differences between individual fruits. The mechanical efficiency that maximizes yield also removes the character that makes each orange unique, preparing the fruit for extraction machines that will complete the transformation from natural product to industrial commodity. The machine that processes your orange juice can crush 600 oranges per minute, but the real innovation isn't speed. It's what happens to the parts you never see. Modern extraction equipment cradles each orange in a specialized cup that slices the fruit perfectly in half with surgical precision. The two halves then press against twisting cone-shaped reamers that spiral into the orange flesh, extracting juice and pulp in a single motion that takes less than 2 seconds per fruit. This represents a complete revolution from older metal prong systems that still operate in some facilities. Those machines drop oranges onto sharp spikes from several feet above, crushing them downward in a violent process that bruises the fruit and releases bitter compounds from damaged peels. The older method extracts juice through brute force, while modern reamers use calculated pressure and rotation to maximize yield without compromising flavor quality. The pulp separation process collects fibrous material in massive metal drums that hold thousands of gallons. This pulp doesn't disappear into waste streams. Instead, it becomes the key ingredient that creates different texture profiles for various juice products. Manufacturers add specific amounts back into different product lines, creating smooth juice with zero pulp, medium pulp varieties, and high pulp products that satisfy consumers who want the sensation of eating whole fruit. Orange peels follow an equally valuable path through the facility. Industrial grinders reduce the peels to small chips that become cattle feed, revealing how nothing gets wasted in this operation. The peels contain high levels of fiber and nutrients that supplement livestock diets, creating a secondary revenue stream that helps offset processing costs. Feed mills purchase these processed peels by the ton, making orange waste more valuable than many people realize. Essential oil extraction happens simultaneously through thousands of tiny pins that puncture peels during the reaming process. These pins, each smaller than a needle, create microscopic holes that release aromatic compounds trapped in the peel's oil sacs. The released oils mix with water and juice, creating a fragrant mixture that contains the essence of orange flavor in its most concentrated form. High-speed centrifuge separation isolates pure orange oil from water through spinning chambers that rotate at 3,000 revolutions per minute. The centrifugal force separates liquids by density, with heavier water settling to the outside, while lighter orange oils collect in the center. This pure orange essential oil becomes a valuable byproduct worth more per pound than the juice itself, sold to cosmetics companies, food manufacturers, and aromatherapy producers. The extraction stage creates a critical decision point where juice follows two completely different paths based on intended shelf life. Fresh juice, destined for refrigerated sections, maintains its natural composition and heads directly to pasteurization. Juice intended for concentrate production moves toward evaporation chambers, where it will lose most of its water content and natural flavors. This extraction stage determines whether your juice will taste like fresh oranges or laboratory-created flavor compounds. The mechanical process strips away volatile oils and aromatic compounds that give oranges their distinctive taste, regardless of which path the juice follows. Even juice labeled as fresh loses essential flavor elements during extraction, requiring flavor enhancement later in the process. The efficiency of modern extractors reaches levels that would amaze early juice producers. But this efficiency comes with trade-offs that affect the final product's relationship to the original fruit. The pasteurization process that follows will complete the transformation by addressing more than just bacterial contamination. When you read from concentrate versus not from concentrate on your juice label, you're seeing the result of two completely different scientific processes that most people never understand. The concentrate path sends juice into massive evaporation chambers, where vacuum conditions remove 80% of the water content without using high heat. These vacuum systems lower the boiling point of water, preventing heat damage to delicate flavor compounds while transforming liquid juice into a thick syrup. The concentrated product takes up 1/5 the storage space and ships around the world in refrigerated containers before water gets added back months later. Both concentrate and non-concentrate juices lose their natural flavors during processing, requiring artificial replacement through carefully designed flavor enhancement systems. The industrial equipment that handles millions of gallons strips away volatile compounds that give oranges their distinctive taste, regardless of which processing method the manufacturer chooses. This flavor loss happens because mechanical extraction and subsequent handling breaks down aromatic molecules that create the fresh orange experience. Flash pasteurization heats juice to 185 DEG, then rapidly cools it to 35 DEG, creating a temperature shock that affects taste molecules in ways most consumers never realize. The heating process kills harmful bacteria and extends shelf life, but the extreme temperature change alters the chemical structure of compounds responsible for fresh orange flavor. Enzymes that naturally occur in oranges become inactive during this process, changing how the remaining flavor compounds interact with your taste buds. The deaeration process removes oxygen to extend shelf life, but strips away volatile flavor compounds that make oranges taste like oranges. Industrial deaerators use vacuum systems to pull dissolved gases from the juice, preventing oxidation that causes off flavors and color changes during storage. However, this same process removes aromatic compounds that give juice its fresh character, leaving behind a product that tastes flat and lacks the bright notes associated with fresh fruit. Flavor pack creation begins when orange oils get chemically analyzed and recreated in laboratory conditions using sophisticated equipment that identifies individual chemical compounds. Food scientists study the essential oils extracted during processing, breaking down their molecular composition to understand which chemicals create specific taste sensations. They then recreate these complex flavor profiles using combinations of natural and artificial compounds that mimic the original orange essence. Blending stations mix juices from different batches, regions, and even seasons to achieve consistent year-round taste that meets consumer expectations. The taste of oranges varies significantly based on variety, climate conditions, and harvest timing, creating natural inconsistencies that manufacturers must address. Master blenders combine juice from Florida's sweet oranges with Brazil's more acidic varieties, balancing sugar levels and flavor intensity to create products that taste identical, whether you buy them in January or July. Quality control testing analyzes acidity, sugar levels, and microbial safety before any juice reaches bottles, ensuring each batch meets strict specifications. Laboratory technicians measure Brix levels to confirm proper sugar content, test pH levels for appropriate acidity, and conduct bacterial counts to verify pasteurization effectiveness. Color analysis ensures visual consistency, while taste panels evaluate flavor profiles against established standards. The natural orange flavor in most commercial juice comes from flavor packs designed by food scientists, not oranges growing on trees. These flavor systems represent sophisticated chemistry that recreates orange taste through precise combinations of compounds extracted from citrus oils and other natural sources. Even premium products labeled as pure and natural rely on these flavor enhancement systems to deliver the consistent taste that consumers expect from commercial orange juice.